All right. I wanted to take a moment to share with you about how to factor trinomials. I know we've worked on this a lot in class, but there is sort of a practice makes permanent kind of situation here. We just really have to do this a whole bunch of times in order to make it work. So I figured I'd go through several examples, some of the quirky ones, some of the ones that you'll see eventually, you may not have seen yet, but I wanted to expose you to several different versions of factoring trinomials or polynomials, basic polynomials, in order to make sure that you have a sense of what you need to be able to do. The main method is almost always exactly the same, but the understanding is really important moving forward. So you're asked to factor this trinomial, and we know that factoring is super duper similar to division, so we're going to go ahead and start like we would any division problem. But I know that this is going to be a 2 by 2 because all trinomials start with a 2 by 2 box. And I know that similar to division, these terms here are going to go x squared negative 16x and 60 into these boxes. Well, the only thing that can go into this box is that x squared, so I'm going to add it to that square, x squared. And similarly, the only thing that can go into this cell is the 60, so I'm going to put the 60 in there. And in class, we've had several discussions about the diagonals. Well, this diagonal is going to be the same product. It's going to have the same diagonal product as this diagonal. So the diagonal multiplication is going to be the same. And I'm going to do that. I'm going to say I'm going to do diagonal, and I'm going to say diagonal multiplication. Well, x squared times 60 is 60x squared. And so, again, my diagonal needs to multiply to 60x squared. Well, what things multiply to 60x squared? Well, there's a bunch. And so I recommend using a calculator and listing out all of the things that multiply to 60x squared. Well, we know that whatever two numbers they're going to be are going to have to be negative numbers because the thing that they need to add up to, like when we do division, is going to be negative 16x. So we're looking for two numbers that multiply to 60 and add to negative 16. So I'm going to start with, let's do negative 1 and negative 60, and negative 2 and negative 30, and negative 3 and negative 20. Negative 4, 60 divided by 4 is negative 15. And negative 5, and negative 12. And negative 6 and negative 10. So I'm just listing out all of the things that multiply to 60. 60 cannot be divided by 7 evenly. 60 divided by 8 cannot be divided by evenly. 60 divided by 9 does not go in evenly. So this is my list. And when I add them up, when I'm adding them up, I get negative 61, negative 32, negative 23, negative 19, negative 17, and negative 16. Oh, look, these two numbers multiply to negative 16, multiply to positive 60x squared, well, x and x, and they add up to negative 16x. So that's what's going to go into these two missing places, and we can do negative 6x, and it doesn't really matter, negative 10x. It really doesn't matter which of those two that it goes into. So now, I wish that I didn't put those blue things there, so let me get rid of them. Well, I think you get the idea. The blue things are somewhat distracting. But essentially, what we're looking for is common factors. So as I look, I need to make that better, 60x, negative 6x, okay. So we've got all of our pieces together now. If I'm looking at common factors, what's a common factor there? Well, this one has an x and this one has an x. So I'm going to pull out an x. X is a common factor there. Well, what made this negative 6x squared? Well, it would have had to be negative 6. So I'm going to pull out negative 6. And then here, to get 60, it's got to be a negative 10. Negative 10 is also a common factor among that row. So negative 10. And last but not least, x. So if I wanted to rewrite this in factored form, I would write x minus 6 times x minus 10, because those are the two factors that come out on the outside. And these two expressions are actually equivalent. I took a really long time to do this one, so I'll go through the next one rather quickly. This process also works with coefficients leading coefficients bigger than 1. In this case, the leading coefficient is 3. So I'm going to make my tabular method box. And I'm going to substitute 3x squared. I know that's going to add up to 16x. I know that's going to add up to negative 12. And so that's going to be 3x squared. I know that's going to be negative 12. And so my diagonal multiplication is going to be 3 times negative 12. So that's negative 36. So we're looking for something that multiplies to negative 36x squared, that adds up to 16x. And so one of those is going to have to be positive, and one of those is going to have to be negative. So we've got negative 1 and 36. Those multiply to negative 36. And similarly, 1 and negative 36. Oh, those are all x's. And we've got negative 2 and negative 18, or positive 18x, and 2x and negative 18x. Oh, hey, look, I don't have to go too much further because I already recognize that this is going to be, when I add those two numbers together, it's going to be 16x. When I add them together, they're going to be 16x. And so one of the places is negative 2x, and the other place is 18x. And now I start looking for common factors. Is there a common factor there? Well, yeah, there's actually two common factors. The 3 can be pulled out, and there's also an x that can be pulled out. Well, what times 3x gives me 18x? 3 times 6 is 18. Oh, well, this has got to be now to make 12 here. 6 times something gave me negative 12. Oh, that's got to be negative 2. Oh, negative 2 is also a common factor among this bottom row, which makes that need to be x, it looks like. Does that work? Yes, it does. So my factored form is x plus 6 times 3x minus 2. This process, if something is factorable, this process always works. We'll do another one because I think it is practical to just keep practicing this. So we've got 3x squared and 4x and 28. The 28 goes there. My diagonal multiplication is 3 times 28, which is 84. That's a big number, so 84x squared. So I'm looking for things that multiply to 84x squared. So 1 and 84, 2 and 42, 84, 3 and 28, 84 divided by 4. I'm using a calculator to help me. 4 and 21. 84 can't be divided by 5. Let's try 6. 6 and 14. 84 divided by 7. I don't think that's going to work. Oh, yeah, 7 and 12. 84 divided by 8. Doesn't work with 8. 84 divided by 9. Doesn't work with 9. 84 divided by 10. Nope, that doesn't work. Okay, we're out of options. So let's see. When we add them together, I get I get 85, 44, 31, 25, 20, and 19. Oops, none of those add to the 4 that I need over there. This is not factorable. And I know that it's not factorable because when I look through all of the possible combinations of things that multiply to 84, none of them add together to be that 4x that I want. So this is not factorable, and I'm going to highlight that because I think that's quite important, that we recognize that sometimes this process is not, we're not capable of doing it. And we know that when we cannot find anything in here that multiplies to 84 that adds to 4x. So that's your justification if you need to provide some justification. This one is actually quite interesting, and I'm going to highlight the label for this slide because we're going to do this by grouping. So notice that there are commonalities here, and I actually have an x to the power of 3. If I were to do something like this, I wouldn't have enough stuff to put places, right? I don't have all of my terms together, so I'm going to look for a grouping of things. Well, if I'm looking for common factors, I see, ooh, there's an x squared, actually, an x squared in both of them. So I guess I can pull out an x squared. I'm going to pull out an x squared, and what do I have left? Well, I have a 6x, because x squared times 6x, minus 8. Can I pull anything else out? Well, is there any other common factor here? 2. It looks like I can pull out a 2, because 6 divided by 2 is a number that I know, and 8 divided by 2 is a number that I know. So I'm going to actually pull out another number, and let's see if I can get blue. I like blue. We're going to pull out 2x squared. What's left over? Well, there's going to be 3x. 2x squared times 3x is 6x cubed. And then divided by 2 is 4. So this would be my factored form, believe it or not. This is the factored form. And it's called factored by grouping. It's factoring by grouping, and it's when we see stuff getting pulled out together that is a common factor. So we can kind of combine this with the old method that we've been using with the reverse tabular method. That's essentially what the reverse tabular method is. It's just a very organized way of doing it. So let's see factoring by grouping in this way. So again, if I were to do the the box method, and we're not going to actually do it all the way, we're looking for something. The diagonal multiplication is going to be 7 times negative 20. 7 times negative 20 happens to be a negative 140, which is a really large number. So when we're doing this is just kind of prep work for me. If I'm looking for negative 140, I'm thinking negative 140x squared, and I'm thinking to myself things that add up to 4. So those are big. I kind of have an intuition of 14 times 10 is 140, so if I want negative 4, it's going to be, 14 and negative 10 is going to be positive 4, but negative 14 and negative 14x and positive 10x, those are going to give me, when I add them together, I'm just kind of like guessing here. I'm talking out my guess. Going to be add to negative 4. So these are the two terms that I want. So when I think about 7x squared minus, and I'm going to do 4x in red, negative 4x minus 20, I'm thinking about how can I rewrite this negative 4x in a way that is going to be helpful for finding groups. So I'm going to rewrite that 7x squared, and I'm going to rewrite the negative 20. But instead of writing negative 4x, I know that this negative 14x plus 10x is equal to negative 4x. So negative 14x plus 10x. And you can see that negative 14x plus 10x is negative 4x. It's just written in a more complicated way. And now I'm going to factor by grouping with these two things. So I noticed that in this term here, 7 goes into 7x squared, 7 goes into 14x. There's also both have an x, so I'm going to pull out 7x, and what am I left with? I'm left with x minus 2. And in this second term, I see that I'm left with 10x and negative 20x. Well, 10 is a common factor, so I'm going to pull out a 10. Excuse me. I'm going to pull out a 10, and I'm left with x minus 2. Well, check it, guys. Look at this. We've got x minus 2 and x minus 2, and then different things multiplying. So what I'm going to do is I'm going to undistribute this. 7x plus 10 times x minus 2. And if I were to expand this, that is my factored form. While it seems a little bit more complicated, this way of factoring could be useful for us moving into more complicated problems. I'm going to do one more and then call this video complete. One more factoring by so we'll actually do this. So remember last time we were looking for things that multiplied 7 times 20 is the thing that's our diagonal. So we're looking for 7 times 20, which is, we found out was 140. We're thinking of things that multiplied 140x squared that also add to that negative 39. And so I'm taking a lot of shortcuts here as well. So I know that both of the numbers need to be negative, so negative 1 and negative 140, negative 2, negative 70, negative 3. Does negative 3 work? 140 does not divide by 3. Does it divide by 4? Negative 4 and negative 35. There it is, right there. There's the stuff that adds up. This adds to negative 39x. So I'm going to rewrite this, 7x squared. And then instead of negative 39, I'm going to rewrite negative 4x and then minus 35x. And then the plus 20 is exactly the same. So remember that those two things add up to the negative 39. I'm just breaking it down in a slightly different way. When I'm looking for common factors of these two groups, so it looks like the only thing that I can pull out is an x. So x times 7x minus 4. And in this second one, it looks like I can pull out maybe, I see that 5 goes into 35 and 5 goes into 20, so I'll pull out a 5, or maybe I'll even pull out a negative 5. I'll pull out a negative 5. Negative 5 times what gives me negative 35, that's 7x, and negative 5 times something is 20, that's negative 4. Oh, look, these 7x minus 4, 7x minus 4, we've got 7x minus 4 times something else, that's x, minus 5, and this is our final answer. It's kind of neat how it all works together. There are a lot of different methods that I showed you in this video. I know it's quite long. Do your best, but I think that this is really going to, practice is really going to take some purpose. So go onto the website, mrgermanis.org, and find some extra factoring practice problems in the class resource section. I know it's really going to help.